Hi class, this is Dr. McGonigal, and right now I'm continuing on with our conversation about data analysis, and we're going to begin with the stages of data analysis. If you have not watched the video that provides an introduction to SPSS, please stop this video and watch that one first. Okay, so there are four high-level stages of data analysis. The first is that we enter our data by hand, typing it in, or we open a data file in SPSS, and we get familiar with that data file. Stage 2 is we clean our data and prepare to run our analyses, and that's what we will focus on next. Stage 3 is we run our descriptive statistics in terms of means and standard deviations and frequencies and percentages. Stage 4 is we run our inferential statistics to test our hypotheses. So I have prepared a data set for you to work with as an example. So click to open the dataset posted in Canvas that's labeled Demo Number 2. And if you need to, just go ahead and pause this video so that you can get that dataset open. This dataset includes responses from college students who worked during the school year. These college students completed a survey, and the survey measured three main constructs, or three main variables. The first is exhaustion from school, and this included 8 survey items or questions. And these are labeled EXH1 through EXH8. The second is work-school conflict, the degree to which work conflicts with school or school conflicts with work. And this was measured using 5 items, and they're labeled WSC1 through WSC5. The third is negative affect, measured using 10 items. And these are neg-AF1 through neg-AF10. There are additional variables, and here is the question wording for those variables. Status, so what is your status in school? Days on campus, how many days per week is the participant on campus on average? Extracurricular activities, does the participant participate in extracurricular activities outside of school and work? And sleep, so how many hours of sleep does the participant get per day on average? Okay, so let me show you what that data set looks like. Hopefully you've been able to open up that data set by now. And it should look like this, where you have your exhaustion items, 1, 2, 3, 4, 5, 6, 7, 8, work-school conflict, 1, 2, 3, 4, 5, and negative affect, 1 through 10. Then you have the number of days on campus, the status, the extracurricular activities, and the sleep. And remember, just like we went over last time in our introduction video, we have a data view and a variable view where we can see information about the variables. Okay, so let's get into stage 2 now that we've completed stage 1 and we've opened our data and become familiar with it. Our data cleaning is what we need to do to prepare our data for analysis. So oftentimes our data is not quite ready to be analyzed yet. And a lot of data analysts will tell you that data cleaning can actually take longer than the data analysis itself, but it's an important and essential step in the data analysis process. So we can think about the steps involved with stage 2, the data cleaning and preparation, as being 5-fold. First, we add value labels and variable names. Second, we examine missing data, like missing survey responses, if that's the data you're working with. Step 3, we recode negatively coded items where necessary. If you don't know what I mean by that, then please stop this video and go back and watch the measurement video for information about that. Step 4 is checking the alpha levels, and 5 is computing scale scores, which we also call composites or averages of item scores. Okay, let's go through these one by one. First, we add value labels and variable names. So in this Demo 2 dataset, this step has been done for you, but you should take a look at it to see what the names and the coding indicate. So for instance, what does 1 mean for the variable extracurricular? Let's take a look. If we go into our variable view, we go into extracurricular, you can see that 1 is yes and 2 is no. And we can take a look at the label, which gives us the question. Do you participate in extracurricular activities? So A 1 indicates that the person, in fact, does participate in extracurricular activities, and 2 indicates that they do not. Okay, so first of all, we check our value labels and our variable names, and we make sure that we understand and that everything is correct there. So number 2, we examine missing data or missing responses. So take a look at that data set that we're working with. Is there any missing data or missing responses in that data set? What do you think? So actually, no, there are no missing data responses in this particular data set. So we don't have to worry about dealing with missing data. And in the data sets that I provide for your project number 2, you won't have to deal with too much missing data. You may have a few missing responses here and there, but I have labeled them for you correctly in SPSS as missing. Number 3, you want to recode negatively coded items where necessary, and this indeed is something that you will have to do for your paper number 2 data analysis. The idea behind this is that many scales include multiple items. I just mentioned that the exhaustion scale has 8 items, Work School Conflict has 5, Negative Affect has 10. So some of these also include negatively worded items. Again, if you're not clear about what I mean by that, please check out the measurement slides and video for more information. So in order to interpret these items the same as the others, you will need to reverse score them. So the next slides will walk you through the steps to recode the items, and I'll demonstrate this using SPSS. A quick note before we begin, always code variables such that higher numbers indicate more of a construct. So if we had a scale of 1 to 5, we would want to make sure that 5 indicated highest exhaustion and 1 indicated lowest exhaustion. So for any variable, higher levels mean more of the construct that you're talking about. In other words, we would not want 5 to indicate the lowest level of exhaustion and 1 to indicate the highest level of exhaustion, because that would be confusing and difficult to remember. In terms of reverse scoring in SPSS, here are the steps. Step 1, you go into Transform and select Recode into different variables. So the reason we choose recode into different variables as opposed to recode into same variables is that we want to maintain the initially coded variable. So if we overwrite the initially coded variable, the sort of raw variable, if you will, in SPSS, and we make a mistake, then we'll have nothing to come back to. So we want to recode into a different variable and create a new variable. Step 2, you select the variables you want to recode from the variable list on the left and move them to the middle using the right arrow. So we have, for instance, our variables listed here. We can select one and that arrow will turn to a right pointing arrow and we put it over here. Step 3, we create a new variable name for the new variable, label it, and hit the change button. So oftentimes I will simply add the letter R to indicate that I have recoded this particular item. So the new variable name that I'm creating here would be part 1R. And the label, I want to say that I am reverse coding it in that label so that I can remember that, in fact, I did reverse code this variable. Step 4, you select the old and new values button. Step 5, you go ahead and change the high values to the corresponding low values and vice versa. You want to click Add after entering every old and new value. You do need to include copies of values that are not recorded. So let me give you an example. If you have a scale of 1 to 5, you will need 1 to become a 5, a 2 to become a 4, but 3 will stay a 3, but we still have to enter it there. That 3 is going to be 3. Then we'll have 4 become a 2, and 5 will become a 1, is the last one there. So in order to get this list that looks like this, we would need to find the box that says old value, and we type in what the old value was. The old value in this case would be 5. The new value here would be 1, so we type in a 1 here, so old is 5, the new transformed value will be 1. Then we click add. And once we have all of our points on our scale recoded for that particular item, we click the continue button. The next step, you can select the paste button to retrieve the syntax file, which I do recommend, or you can click OK to skip the syntax creation. So why would you want to give yourself an extra step in creating syntax? Well, the reason is that this is a lot of steps to remember to do. And if you happen to lose the file that you're working with somehow, you didn't save it correctly, trust me, it happens a lot. If you do save your syntax, you can simply rerun that syntax with one click of a button rather than having to go back through all of these steps to reverse code your items. Step 7, if you do create the syntax, you want to label your syntax. So add some text at the top of your syntax to indicate what you're doing here with that syntax. So in this case, we're reverse scoring this item. So we type that in, and if we use asterisks, it'll gray it out, meaning that SPSS won't run that. And this is the code it generates. So it generates this term recode, and then you can see here that it makes 1 a 5, 2 a 4, 3 a 3, 4 a 2, and 5 a 1 into our new variable. And it adds the variable label as well. And execute means that SPSS will execute it. So if you highlight this and then click the green button, it'll run your syntax. Or if you don't want to create your syntax and you just want to have SPSS run it for you, then you simply click OK. Okay, so let's go through a demonstration of recoding a variable using SPSS. So let's say I want to recode EXH2. So I have determined that EXH2 needs to be recoded. And how do I know that? Well, if I was working on my paper 2, like you will be, I would go to the codebook, and the codebook tells you which items need to be reverse coded. So let's say I've already done that, and I know that EXH2 is in fact an item that I need to. I go into transform, and I say recode into different variables. And now that I can see my variable list here, I'll show you a quick tip. If I click on any one of my items and then I right click with my mouse, I can say display variable names, and I can easily find EXH2. So I move EXH2 over, and here's where I need to create a new name for my new variable. So I'm going to say REXH2. That's going to be my recoded variable name. And my label will be recoded EXH2. So now I click change, and I click old and new values. And because my exhaustion scale is on a 5-point scale, I'm going to enter a value of 1. Old value of 1 becomes a 5. And I click add. Then an old value of 2 becomes a 4. And I add. Remember that for this one, for a 5-point scale, a 3 will have to stay a 3, but I do need to include that. A 4 will become a 2, and a 5 will become a 1. Okay, so now I have all of my scale points transformed. I click continue, and I am going to click paste to create a syntax file. So this is what my syntax file looks like. I'm going to add a label here that says recode EXH2, so I remember when I reopen my syntax file that that's what it is. And I have my code here. Now I can simply highlight the text and click the green button to run it. And if I go to the bottom of my data file now, I have my new variable name, REXH2, with the label recoded EXH2. And how can I check to make sure that it recoded correctly? Well, if I want to, I can actually grab this REXH2 and like kind of move it up like this and put it right after EXH2. And then if I go into my data view, I can see here that a 2 has indeed become a 4, a 3 is the same, a 4 has become a 2, a 5 has become a 1. So just by quickly eyeballing it, I can see that it appears that my variable REXH2 has been recoded correctly. Now, one warning for you as you're going about recoding your variables for your paper number 2, not all items are measured on a 5-point scale. So if it's a 7-point scale, then you need to also include 6 and 7. If it's an 8-point scale, whatever the scale is for that variable, you need to make sure that you're including all of those numbers when you're recoding. Okay, so now that we have gone through recoding negatively coded items, we've also examined our missing data and we've added and looked at our value labels and variable names. The next step 4, is checking our alpha levels. So if you don't know what I mean by alpha levels, then please stop this video and go back and watch the measurement video where we talk about internal consistency, reliability, and coefficient alpha. The idea is that composite variables are construct level variables that consist of the average or the mean of the multiple questions or items that measure that same construct. So for the previous example, we had 8 items measuring exhaustion. We don't want to have to analyze 8 separate items. We want one score that indicates the participants' overall levels of exhaustion. So in order to do that, we create an average or a mean of those 8 items together. So we will soon learn how to create composites, but first we need to learn how to compute Cronbach's alpha, which is also known as coefficient alpha, or internal consistency reliability, again, that you learned about in your measurement module. So in order to calculate coefficient alpha in SPSS, step 1 is go into Analyze, Scale, and Reliability Analysis. Step 2 is move the items over that go into the composite variable. Step 3 is you click the Statistics button. Step 4 is you select Descriptives for Item, Scale, and Scale of Item Deleted, and click Continue. Step 5 is select Paste to put the syntax, put your syntax into a file and run syntax. And here's what you get for your output file. So if you do all this, you will see that you get, first of all, a box that tells you how many cases were used in the analyses. And this should be the same as your sample size unless you have missing data. So if you have some missing data, you might notice that this number is a little bit different than your overall sample size, a little bit less. This box here gives you your coefficient alpha. So under reliability statistics, this is what you're looking at. In this case, it's 0.836. We would round that to 0.84. This next one gives you descriptive statistics for all of your items. We're going to talk about descriptive statistics later on. And this next box, box 4, provides you with some information about how to potentially improve the reliability. So if you have a really low value here, and again, if you're not clear on what this means or what a good value is, then go back and review your measurement slides. If you remember, you would think that you need something that is at least 0.7, right? So this is 0.836 or 0.84, which is greater than 0.7, so this is okay. But if we get something that's much lower, say 0.3, 0.4, 0.5, even 0.6, we might want to take a look at what is going on with our scale that's giving it low internal consistency reliability. To do that, we might look at this box 4 here, which gives you Cronbach's alpha if the item is deleted. What this is telling you is if we were to remove each of these items in turn, so part 1, if we were to remove part 1, our alpha would become 0.785. Well, 0.785 is lower than 0.836, so that's an indication that we should probably keep that, that item in there. So in all of these cases, there's nothing that would really improve the alpha very much. So we don't want to remove any items. So this is basically, this box 4 gives you some diagnostics. And if you're getting a negative alpha or a very low alpha, it can help you maybe determine whether one of your items is the wrong item that you're including, or if maybe you've forgotten to reverse code it. Box 5 is the scale level descriptive statistics, which we don't need to pay attention to here. Okay, so now I will demo how to run your coefficient alpha using the example data set. So let's look at work-school conflict. We have, again, 5 items to measure work-school conflict, WSC 1, 2, 3, 4, and 5. So we will go into Analyze, we will go into Scale, and then we will click on Reliability Analysis. I'm going to right-click in my variable names so I can display the variable names. And I will find 1, 2, 3, 4, and 5. If I hit Shift and then Enter, it can help me grab all 5. I move the items over to my items. I click on Statistics, and it brings up another box where I click Item, Scale, and Scale of Item Deleted. Then I click Continue, and I click Paste to create a syntax file. So it has pasted it into the same syntax file that I have already been using. And so I can label this. I was going to say reliability, but I'll say alpha for WSC for work-school conflict. Okay, so here is the code that SPSS has generated for me. I can just highlight that code and click the green button to run it. And in my output file, I get the reliability. So in this case, you can see the number of participants in the second box here, the reliability statistic, 0.96. So that is telling us that the alpha is good. It's above 0.7. Now if I go into Cronbach's alpha of item deleted, there's really nothing that I need to do here to create a higher level alpha. So it all looks good. Now remember, like I said before, you want to save your files. So I have my output here. I want to go into File and Save As, save it to the folder that I'm working with. Same with my syntax, File, Save As, make sure I'm saving my syntax, and save my data file as well. So don't forget that you should be doing that periodically throughout your data analysis process. If we want to report our reliability in our methods section, we could say, participant decision making was measured using a 5-item scale. 1 item was verse scored. Reliability analysis showed that the scale had a good reliability. Cronbach's alpha equals 0.84. Therefore, a composite variable was created. Instead of writing Cronbach's alpha, you could also use this statistical symbol of A for the lowercase a for the Greek alphabet. Either would be acceptable in this case. This is just an example. This variable decision making is not the one that we just went through, but just to show you what that would look like if we were to write it up. Okay, so now we've checked our alpha levels and we've done each of the other steps, the other 4 steps that come before it, so we can move on to computing scale scores, also known as composites or averages of item scores. Composite variables, again, are single variables that average the scores across all items in a scale. For example, you could create composite variables for exhaustion, work-school conflict, and negative affect using this data set. So if we are creating composite variables in SPSS, the first step we go into Analyze, Transform, and Compute Variable. Step 2, we create a variable name. Step 3, we type the word mean, so M-E-A-N in open parentheses. And then after that, we move our variables of interest that we want to be included in our composite variable over from the left-hand side into that numeric expression. When we're done, we have all of those ones that correspond with our variable. We close the parentheses. Step 4, we click Paste to paste into a syntax file. And again, this is one of those where you really do want to create syntax, because if you lose your data file with these composite variables, it's kind of a pain to go back and redo all of this. A new variable will then appear in your data set at the bottom of your variable list in variable view, or the far right in your data view. All right, so I will demo how to create a composite variable using that work-school conflict item that we just ran our coefficient alpha on. So we know that our work-school conflict scale has good internal consistency reliability. So now I can create my composite variable. I go into transform, compute variable, and I have to name it, right? So I'm going to name it comp for composite work school conflict, WSC. My numeric expression, remember I'm typing the word mean, MEAN, open parentheses, and I'm going to go into my variable list and display variable names. So I have WSC1, comma, WSC2, comma, WSC3, comma, WSC4, comma, WSC5, and that's it for my work school conflict variable. So I close the parentheses and I click paste to put it into my syntax file. Here is my syntax file, and here is the code that it created. The code always goes to the bottom of your syntax file. So I highlighted that code. I click the green button to run it. Now I'm not going to look in my output file because it hasn't run a statistical analysis. Where I am going to look is my data file because it has put a new variable at the end of my data file. So if I'm in my data view, like I am here, I scroll all the way to the right and I see my composite for work school conflict here. If I go into my variable view and I scroll all the way down, I will see composite for work school conflict has made it to the bottom of my variable list. Okay, so we have finished our data cleaning. Congratulations. We are ready to move on to stage 3 in our stages of data analysis, which is our descriptive statistics.